All right, welcome everybody. We'll get started here in about a minute, just waiting on a few others to join. If you're here for the Red Hat OpenShift Virtualization Roadshow, you are at the right place. So we'll get rolling here in about a minute. Mike, can you hear and see everything properly?
Yes, everything's working
Okay,
correctly.
just making sure. All right, well, welcome everybody. Thank you for attending the Red Hat OpenShift Virtualization Roadshow. My name is Todd Millard, and I am CEO of Crossvale. We are presenting this roadshow together with Red Hat, and we hope to help you guys understand a lot more about the OpenShift virtualization. So that being said, we're going to talk a bit today about the overview of what you're going to be seeing. We'll do this a little bit of presentation in the beginning that kind of walks through some slides, understands OpenShift virtualization, gives you a better understanding of that for the foundation before we get into the virtualization lab. And then we will have a wrap up and next steps after that. Little bit of housekeeping on here. If you have any questions, please use the chat mechanism in there to ask questions. And also right now, I will introduce a few people that came here with us from Crossvale. We have Mihai, who will be leading our workshop. Also, Jose Alonso, who is our CTO, that will be here to be able to walk through some of the technical slides. Mike Cohurst, who is here from our sales side, to be able to help understand, any questions that people might have on a sales related thing. And we also have Nacho that's here from our infrastructure team. He runs our infrastructure team globally to be able to help answer any questions as we're going through this. James, Garrett, do you want to introduce proctors that are on the Red Hat side, just so people know who's here?
Sure. Yeah, it's just it's me and Christian Trujillo from Red Hat side. We're both Red Hat SAs and on the ecosystem pool team. And yeah, we're here to help out, answer any questions that people have.
All right, very good. That being said, we'll kind of roll into here first. A little bit of introduction, tell you about who we are, and let you know a little bit about who you work with today and why that matters. And what we've accomplished, just so you can kind of get an understanding of who's presenting to you. So Crossvale specializes in enabling application and ops teams to run their critical workloads on container-based infrastructure. And here's why this sets us apart. We guarantee 60% faster operational success in less than 90 days. Now, I know some of you might think that sounds like marketing speak, so let me give you a little bit of substance behind that statement there. We've been doing this for 24 years. This is not 24 years of just general IT consulting. It's been many, many years of proven experience in infrastructure and application transformation. We provide 24/7 service and support because we know your systems don't take nights and weekends off. We are there to make sure everything is running for you properly. We're not a small regional player. We operate globally. We have operations across the US and EMEA with headquarters in Dallas and then also offices in Belfast in Spain. We work with you, or when you work with the Crossvale, you're getting a team. You're not just getting a one person that's in your organization. We understand how enterprise scale challenges need to be solved. But here's what really matters: industry recognition for results. Red Hat has named us Container Platform Specialist of the Year. We've been commercial partner of the year 3 times. We hold specializations in status, both mission, critical automation, and container management. That being said, we also have won awards with Portworx as Portworx Partner Innovator of the Year, which shows that we know how to work directly with best of breed systems to be able to build you a solution that works best for you. So why I'm telling you this is because when we talk about infrastructure modernization, container platforms today, it's not theoretical. Everything we're covering comes to you from real implementations with real organizations facing some challenges that you are facing today. So that being said, now let's talk about why you are here. Let me move to the next slide. So I'm gonna guess it's not because you just had nothing better to do on a Wednesday. So you're here because you notice the shift happening in the industry and want to understand better how to make decisions around the shift. The server virtualization industry is changing dramatically, and I mean dramatically. The solutions that got us here, the approaches that we've been using, the gold standards over the last few decades are not necessarily going to be the solutions that take us forward. So quick hands, how many of you are feeling pressure from leadership to modernize, to be more agile, or to do the same with smaller budgets? See a number of hands going up. This is common. Exactly. The pressure you're feeling is not going to go away. It's only going to get worse. So, but here's one thing. Change creates opportunity. While the industry transformation might feel overwhelming, it is actually opening doors for solutions that can make a critical change in your infrastructure to create more efficiency, more resiliency, and honestly, make it easier to manage. So that's why you're here today. And that's exactly why Crossvale specializes in helping organizations navigate these transitions. We've seen firsthand how teams that get ahead of the curve end up in a much better, stronger position. So today is not just about learning new technology, it's about considering your options. Because the best time to evaluate alternatives is not necessarily when you're forced up against the crisis in the mandate, but when you have the luxury to be proactive. Now, I know in the situation right now with Broadcom and a lot of things related to VMware, some might be in a situation where you're up against that crisis. Some may be in a situation where you have multiple years. But it's better to figure out how to make those decisions when you're not under a crisis. That brings me to what we're going to accomplish together today. So before we dive into what we're going to do today, let me paint the picture of where you've been walking. Okay, by the end of the day, 3 things are going to happen, right? So these are the things you're going to walk through today. First, you're going to seriously be able to take a look at this OpenShift virtualization platform and understand what this alternative solution is for your virtual infrastructure. Not because what you're doing now is wrong, but because there may be a better way forward. Second, you'll become genuinely familiar with the Red Hat OpenShift virtualization, not just from I've heard about this platform, but you'll actually understand and see it in action so that when you're talking internally with people, you'll have a better understanding of what it can actually do. And third, and this is a big one, you'll understand that your migration and infrastructure modernization journey starts right here today on this workshop. So now I know some of you might be thinking that sounds great, but my environment is complicated, or we've looked at all kinds of alternatives before and they didn't work out. We're having problems making decisions on this. And I get it. Change is hard, especially when you're responsible for systems that can't go down. And also the systems that you've been working on is intricately designed into your IT systems today. VMware is very pervasive. But here's what we need to consider. Crossvale has guided organizations through this exact journey from where you are now, whether that is already starting the journey or trying to figure out how to start the journey. and how to modernize efficient infrastructures that actually make your job easier, not harder. And we do this teaming up with Red Hat. We find that Red Hat's platforms have the best solution here for moving forward with virtualization. I'm not saying I'll leave you here ready to rip out everything and start tomorrow, but we will leave you with a clear understanding of your options and a roadmap that makes sense for your specific situation. So with that vision in mind, let's move forward to seeing what we will cover. By the end of the day, 3 things are going to happen. Actually, I'm sorry, 4 things are going to happen. First, how many of you prefer learning by doing rather than sitting through slides? Definitely. We got the hands up. Okay. And just so you know, we will move into the workshop after we get through a few of these slides and move into some of the technical slides. We're going to tackle 4 game-changing areas in today's hands-on workshop, including live migration techniques. So the virtual machine provisioning management will cover live migration techniques that will help you transform how you handle maintenance and deployments. Next, platform essentials. We're getting into the nuts and the bolts of the storage, the networking, the load balancing, all of everything that works in your environment. And then the migration strategies from vSphere to OpenShift. And before anyone starts sweating, we're going to make this approachable and practical. And then backup and restore, because solid disaster recovery shouldn't just be something that keeps you up at night. So now here's why I'm excited about talking about this agenda today. Every single thing we're covering addresses real challenges that infrastructure teams are experiencing today. So let's talk a little bit about the activities that you're dealing with currently. If you're like most folks that are, working in virtualization infrastructure, that are administrators that we talk to, your day probably starts with troubleshooting. Maybe it was a hypervisor throwing storage areas or storage errors, or it's network performance issues, users calling that, need help from the help desk, but, a lot going on. This slide captures what we hear from IT professionals every single day. Your role has evolved far beyond just keeping the lights on. You're juggling everything from Active Directory management, Sarbanes-Oxley compliance, auditing, Intel microprocessor troubleshooting, and maintaining those critical Windows server images that everyone depends on. And here's what the real challenge is. While you're doing all the tactical work that you're expected to do, you're also expected to be strategic. So you're expected to collaborate with engineers and security team, and you're supposed to be implementing new policies and optimizing performance and somehow finding time to plan for future needs. So at Crossvale, we work with organizations who recognize that this workload isn't suitable with just traditional approaches. And we've helped dozens of organizations navigate through this change. That this is not just a technical change, there's also processes change and a people change that we have to go through to be able to help you be successful. So we talked about all the activities that fill your day, and let's be honest, what makes those activities harder than they even need to be? When we will look at the different challenges of traditional virtualization platforms versus modern virtualization platforms. And it's not just about cost. Traditional platforms are showing their age in very, very critical ways. So, some of the things we're dealing with: slow evolution, How long does it take to implement new features or capabilities in your current environment? Months, sometimes years. And let's be honest, what kind of R&D are we going to start seeing out of Broadcom? Is there going to be a lot of evolution in that platform? Difficulty supporting growth when you need to scale. It's rarely as simple as clicking a button. It's planning, procurement, implementation cycles that drag on. Risk, both technical risk and aging infrastructure are issues, and this builds additional business risk from being locked into proprietary solutions. Then we have developer productivity hurdles. Your development teams are probably asking for containerized environments, DevOps tooling, CI/CD pipelines, and current virtualization platforms is making this conversation much more complicated. So, but there's an exciting solution out there. If we think about what challenges are being solved by the modern platforms, we're reducing operational infrastructure costs, not just lowering licensing, but we're actually simplifying management and reducing the operational overhead. And this is something also Crossvale helps out with, where we have a team called the PodOps for OpenShift team, where we actually can take on these capabilities for you over time. Capabilities that, if we look at like the innovation of speed, what we're looking for is capabilities that used to take months to implement, now are being deployed in just days or weeks. We're adding true scalability, horizontal scaling, and that actually works when you need it. And then security focused, built-in modern security paradigms, not retrofitting. So we need to have the security team involved to be able to help them understand how to solve these problems. And then integrated development tools. So finally, infrastructure that makes your developers more productive instead of creating friction. This gives them the ability to not spend so much time on administrative work and more time on development. And then that's exactly why Crossvale specializes in these platform transitions. We've been organizing these transformations for companies for many years, and we have automated methods to help make this happen. Let's move forward to the next slide. So if we think about, we frequently hear from our customers, the conversation that we have with them typically fall into topic areas of migration off their existing traditional, virtualization platforms, or how they can leverage OpenShift virtualization as part of their infrastructure or application platform modernization strategy. With the current disruption in the IT industry surrounding virtualization, many organizations are actively investigating alternative virtualization platforms with the intention of migrating their existing virtual machines into a new platform. This migration of their VMs are top of mind for many customers. This conversation is very, very complex in some situations, and in other situations, there's a lot less complexity, but everybody is trying to figure out how to solve for this today. And then if we think about Red Hat OpenShift Virtualization and what it's bringing to the table. OpenShift Virtualization preserves traditional VM behavior and administrative actions like live migrations and can support your business critical applications. OpenShift Virtualization is built on KVM, so this technology has been around a long time. It's been used by Red Hat and most of the cloud providers for over 15 years. KVM powers the VMs in trusted products like RHEL and OpenStack. It also is used in public cloud offerings. Windows guests are supported through Microsoft Server Virtualization Validation Program, SWP. And it also includes unlimited RHEL guest licenses. So the upstream product KubeVirt combines KVM layer with OpenShift manageability into its ecosystem. The overall solution here is when we think about virtual machines and hypervisors and making a choice to go from a your current hypervisor onto a new hypervisor. What OpenShift and OpenShift Virtualization brings to you is a modern platform where you can run containers and VMs side by side. So you can modernize at your own pace while still dealing with the legacy infrastructure that you need to be able to support your VMs. That being said, I'm going to hand this over to Jose Alonso, our CTO, to talk a bit about some of the more technical aspects of this. Jose?
Hello. Hello, everybody. Am I audible?
I can hear you, yes.
Perfect. So when we're looking at this problem that Todd has been presenting to us, I want to have three main goals for this intervention. I don't have a lot of slides before the workshop. I'm not going to eat a lot of time, I promise. I'll go a little bit fast and focus only on what I really want you to take a look while you are doing the workshop, so you can really pay attention to where the value is in the offering. So my three goals today is: one, let's fully qualify the problem; two, let's demystify the migration. Let's make sure that we can migrate, and migration is not the source of nightmares anymore, or at least we have it under control. And then what are the options and what is the future for this platform? As Todd was saying, like, if we are thinking about moving from one hypervisor into another, like, we have been here before. Like, whoever has been working with Kubernetes for a little bit of time, you would remember that Kubernetes was at the beginning challenged by Pivotal. That was another application platform. And we saw how the community chose to work with Kubernetes, and the same thing is happening now again on VMs. The rate of innovation is exponential. The more customers are in it, the more the companies invest in it, the more solutions we have available, and the higher maturity level that we get out of those offerings. So once you make the decision, I do want to migrate here. Like, what should I be worried about? Well, there are a few things that are very, very nice about this migration. This is not a migration that you need to do as a big bang, and that gives you, or should give you, some peace of mind. So when Red Hat started looking at, let's see how can we bring VMs, of course, the first question was, all right, but we will need to migrate them. It's not only to serve VMs and to have this capability, we need to be able to migrate from different sources. So they created this toolkit that you will see, and you will play with it today, where you can migrate VMs and have an iterative way of migrating VMs. So can you go to the back? Thank you. You can, from this toolkit, you will, it allows you to migrate in different waves. It allows you to migrate workloads that are not mission critical first, and then keep evolving and learning through exercise and repetition. Once you start migrating, you will see, and you will experiment this today. This is one of the things that I want you to pay close attention, that when you're working with VMs, even though the names change, the capabilities are very similar. So we have a thing called live migration, where a VM moves from one node to another. I don't want to go into what is the name in another platform, because there are multiple platforms out there, and I don't know which one is the one that you're using. But from a capability standpoint, you have that option that basically the VM lives and it's moving while it is serving, which was difficult to achieve, but now we have it available. And it worked pretty well. You will test it today, and you will see how it works. Once you get into, can we move to the next slide, please? Bob? Once you get into this migration toolkit, you will see how it integrates into multiple virtualization or multiple hypervisor. Today, you're going to choose vSphere, but you can connect to an OpenStack, you can connect to a Rev environment, you can connect to other platforms. The idea with this is that once you select the VM, that VM moves from the source to the destination, being the destination within OpenShift. And once it's running inside of the cluster, it's a part of the cluster, which means that it can communicate, it uses a storage, it can connect to the network, and we have all the capabilities that Kubernetes provides from a network management perspective. So it is, I don't think it's fair to do a comparison one-to-one because the capabilities of Kubernetes were developed for a more modern automation or capable infrastructure. The things that the applications need nowadays are a lot more advanced than what we used to have when we were running on VMs. And that is, on one side, pushing the VM capabilities to deliver these functions, and on the other hand, getting the Kubernetes features so advanced that the gap keeps growing. So when we have developers that are asking for cloud, they are not really asking for cloud. They are asking for that level of capabilities, that level of features in the infrastructure. And some of you may say, well, if you automate a lot the platform, I can achieve that with the provider that I have today. Yes, and I have not seen that. Like the reality of the world is that the automation level in the customers where we go, and I work with top 5 banks in the United States, there is not at the same level of, like, even at the simple workshop like what we are having here, you can achieve quickly. So if we go to the next slide, Todd, please. So this is how the VM lifecycle works inside of OpenShift. You see that we have Ansible there in the middle. Automation is the keyword. It was the buzzword before AI. I still like it. Like automation is still one thing that I do like. So with this automation, you will see that the key or the entry point of the cluster is the API. That's what the cluster gives you. An OpenShift cluster is composed of multiple nodes, multiple types of nodes. Each node, which is a machine, is a node like a hardware, like if you're running bare metal that is required to run virtualization, is a single machine. That's what we call a node. And there are several types of nodes. We have worker node, we have control plane node. There is also control hubs. There are other type of nodes, storage nodes that we can use to optimize the platform to the need. These nodes, they can provide GPU, they will provide the CPU, the memory, the network. We can map network directly into the VM. We can virtualize the network. We can do all of those things. And when we have all of that set up, that becomes a file that we can host. So the VM gets translated into a YAML file that we can host in Git, and then Ansible and GitOps can take care of the entire lifecycle of that VM. It can run in one, or it can run in multiple clusters. You can orchestrate backups, orchestrate deployments, and orchestrate in general pipelines that, yes, again, you can achieve the same thing, the same result with the current offerings, but again, not that I have seen to this level of maturity or this level of results. So if we go to the next slide, and I promised that it was going to be it's going to be short. I have 2 more slides and are this type of use cases. So if we look at when we started this conversation with customers, everybody was saying, well, but you're new to the game, you don't know enough, you don't know how much, you don't know how complex my VMware environment is. And you're right, we don't know how complex your VM environment is. Your environments, they have grown over the years, and the complexity around them has grown based on the capabilities of that platform. And in many cases, your company has changed to adjust to what that platform was capable and was ready to do. What we do with OpenShift Virtualization is to give you a new set of capabilities, to give you a much more modern way to manage VMs and to be able to co-locate VMs and containers, to be able to have a very robust platform, to be able to automate the entire lifecycle, to be able to do, and in general, a whole modernization of this infrastructure. So if we keep going, I have a few more slides. I'm sorry, it's just 5 more slides of things that I want you to take a look when you go into the workshop. Now, as I was saying, let's imagine that you want to migrate. And just imagine that when you go into your workshop today, you're looking at your brand new cluster. I have a new cluster that is my destination. Okay, how do I go from where we are today, this legacy virtualization that we have on the left, to this DevOps modernization that you are talking about, where we have these GitOps and all of these containers and VMs and all of this running? It looks very complex to me. At the beginning, anything that is unknown is complex. And when we look at things and we start understanding them and we start playing with them, that complexity becomes knowledge. And it becomes a second nature for us on how to work with the platform. So if we look at these 3 stages, we have legacy virtualization where all my apps are in the VMs. Then we go into a migration from host. Now we are re-hosting these VMs. Nothing has changed. We are still running VMs, but instead we are just changing hypervisor. Nothing has changed. We increase the IT efficiency, we increase automation, we decrease response time, increase the satisfaction of the customer. But the goal should be over time to really transform our footprint and go from VM heavy into containers heavy. How does that change happen? So let's dig a little bit deeper. If we do like a zoom in into this, how would that happen? So in the world of once we have in the initial phase where we have the VMs, how are we gaining the time back so we can focus on keeping modernization of the platform? Well, if we automate the way we propose the automation to be, you'll see that you can enable self-service portal, you can assign roles, you can move all of this decision-making that happens after a request is made to catalog items. So you have a catalog where everything is built into the catalog. Everything is done preemptively. So when you click and you select it, it automatically goes. Again, we are building templates. Those templates are YAML files. I can choose that YAML file, deploy as many times as I want, and create as many units as I want. So what happens next? What is the next step to this? And how does it compare to what I have today? So can you go to the next slide, please? So one more. So this is more the reality of what I see in the customers. When I go and I talk to customers that are starting their journey into this, or where, like even when we were delivering services for automation on top of other hypervisors, we would get involved when they have like backlogs of, I have 5,000 VMs that are still waiting provisioning, and my average time is 45 days. Well, that doesn't really look like VM in a day or VM on the spot or self-service or modernization at all. Like what happens in those environments is that the development environment, the development teams finds ways. This is like in Jurassic Park that the life finds a way. The developers will always find a way to get their way. So if you don't give these capabilities to them, they are going to go to the cloud, they are going to create a silo, they are going to do something that allows them to work at the speed that their business is demanding. It's not because they want, it's because they are forced to provide that result. And if we can't provide this infrastructure in time, they always find ways to shortcut the system. So how can we improve this with OpenShift virtualization? Like how much change is there in this pipeline? So if you see what we have on the left, that's a virtual machine. That's a definition of a virtual machine. What do we want to have? Or what are the rules, the DNS, the names, the IPs, and everything? That is the request. So let's focus on that part and go to the next slide, please. If you see, that definition didn't change much, but that definition now, that is the YAML that defines the virtual machine. And the moment that we have that, we can just request OpenShift to give me exactly that. And OpenShift will. Now, I don't need to go, of course, all of this needs to be preset of what can be requested and how much, and put the limits and put quotas on users and namespaces. All of those rules can be established. But the idea is that we are enabling them to be able to go from recipe to have the VM ready and no intervention at all. There is nothing in the middle. We can integrate this with a CMDB, with ServiceNow, with Remedy, with anything that is managing your platform. And given the right approvals, this is triggered. And there is no manual effort involved in this. So again, I know that you can achieve the same result, but it's not likely or not common that I have found anywhere anything close to this level of maturity. So if we go to the next, let's talk a little bit. Did you can you move to the next slide, please?
Trying to, hold on. There you go.
So,
oops. There you go.
Okay, perfect. Thank you. So, as I was saying earlier, okay, we now can provision VMs. And how does it work? How do I co-locate a VM with a container? How do I achieve that a container can talk to my VM in the same SDN, in the same software-defined network, without having to route or complicated routing or things that I do not want to expose outside of the cluster? So what happens now is that the virtual machines, from a cluster perspective, is just another object that is running inside. So we can apply the same networking, we can apply networking objects, we can apply network policies, we can apply all of the same things that we had for OpenShift and Kubernetes that now apply also to VMs, and my containers can talk to them. You see, we have a thing called GitOps here. So let's dig into what GitOps is. This is something that I don't think you will see in the workshop, but I do want to touch base on this.
So, Jose, the last couple of slides said you went from many days to get a VM to just minutes, right? Isn't that what you were saying?
This should be immediate, yes.
Yes, okay. Yeah,
But
I mean, I just wanted to make sure I pointed out that was what it was saying. It was saying many, many days, multiple team members have to deal with it now. But once OpenShift virtualization gets implemented correctly, you're talking same outcome could be done in minutes.
Correct.
Okay.
Again,
right.
it is achieved with coordination upfront, like what can be done, like what limits and what rules do you want to set upfront, so people can know what can be requested.
But you come in with somebody that knows how to do this and build this once up front, and then you're able to then have that result happen in minutes every time after that, rather than having to keep doing the same things over and over.
Correct.
Okay. All right. That's amazing.
So if we look at that particular box that was kind of new, some people are using it, not many people are, the GitOps box. So how does GitOps work? What does it do? So GitOps, this is one of the not new things, because it's a little bit like, it's not old. But the thing is that it changes you. Once you start using it, you want to do absolutely everything with it. So think about it like if you had an agent that is running and is always checking that the defined state matches the real state. So let's say that I want to run 15 VMs for my development environment that all run with 4 vCPUs, 32 gigs of RAM, they run JBoss, and they run on this LAN with this network with all of this configuration. I put all of that in a YAML and I define how I want that to run for GitOps. So let's imagine that my cluster suffers and a node is lost. And all of those objects, they die or they have to reject or they have to be recreated. Well, GitOps takes care of absolutely everything and recreates everything. You have two levels of recreation. One is OpenShift itself that will detect you have lost objects and they need to recreate them. But you have also a second level of supervision. That is, if you have a user that goes and change something in the cluster itself, if that change is not matched to GitOps, you can do an override. So your policies can be defined in GitOps, and then nothing can override them if you set it up that way. Again, there is many ways that you can define how you want your GitOps to work. This is, for us, was one of the big revolutions. GitOps, we use it for applications, we use it for containers, we use it for creating ephemeral environments, for doing A/B testing, for doing blue-greens, for doing all kinds of automation. We do it for reporting. Like for us, this GitOps takes care of all the CD, part of the CI/CD. The CI, you can build it in Tekton, you can build it in GitHub Actions or in ADO, in anything that you want to run. But the CD component, the part that is matching the stage, it works great on this GitOps. And it gives you a very nice dashboard as well, with roles and roles-based access control on who can do what.
So not only can you change things so you can build things in minutes, if things break, they can fix themselves.
So where we, just so we can get a clear picture of how this is super useful. We have a customer that they don't run mission critical workloads in their cluster. So they can afford to have downtime. If something breaks, they can recreate the cluster at will, right? So the cluster build is heavily automated. Once you build the cluster and you adjust it to your environment, the building and deploying of a cluster, it doesn't take long to do. So in this particular customer, they have more than a 4-hour SLA to reactivate service, and it's not a massive cluster. So what we have with Tekton and with GitOps is the option to say, well, if the cluster is gone, I want to create a new cluster and redeploy the same configuration that we had in my old cluster. And all you have to do is one line of code change. That is, what is my new cluster? Where else do I need to run the same configuration? And everything deploys, absolutely everything. Configuration maps, secrets, services, service accounts, all of it deploys from GitOps. So that gives you a lot of flexibility when you have clusters that you can afford to lose. It also gives you a lot of flexibility when you have like active type of scenarios, active passive for backups. And in general, it's a simplification of a very complex pipelines that we used to have, and now it has become like it's just nothing. It's the same thing over and over again.
So someone that might have invested in CI/CD using older technologies could get value out of moving to Git because it's the newer iteration of this. Is this correct?
GitOps to GitOps.
Yes.
The CD component, like if you are very happy with what you have and you are happy supporting it, by all means, just keep running it. But I would evaluate it. I would evaluate if I want to keep supporting what I have, because likely it's consuming a significant amount of manpower. and move into more of an agent-based deployment like GitOps and not have to do all of that definition of pipeline, error control, error flows, notification, and such. You build all of that once with GitOps, and that's it. All right. So if we, as we were saying, like the goal is not to just move VMs. You can move VMs and it will work, and it will work for a while. But the holy grail is to give your developers the speed that they want. And the speed that they want is not to run on VMs, is to reduce the size of that to containers. So if we look at the sample that we have in here, we have a legacy virtualization. We go and everything runs as virtual machines and going from the bottom. So we have inside of OpenShift a namespace where everything is a VM. We have multiple JBoss application, a couple of Apache, and a database. And everything is inside of VMs, different VMs, right? As we modernize, the first thing that we do is move the database into a container. This is not where I would start, but it is where this slide starts. There are databases that run very well on containers, but traditionally, this is likely the most complicated part to move to the container is the database. So the easiest part, in my opinion, to start would be the Apache, because Apache is a very simple solution, very lightweight, and likely with very, very little code that you need to change. So push that Apache, serve it up, and then push that compute down as well. Then move the JBoss into, like in this case, it uses WebLogic. I will not use WebLogic. I will use something more like a Spring Boot or more of a Java framework that allows you to run. And that gives you all your applications now running in containers. Those containers can be auto-scale, scaling up, scaling out. They can join different groups. They have a lot more capabilities and a much smaller footprint than your VM. And that gives you a lot of infrastructure back on this case. So I think the next two slides that we have are success stories. And I don't really want to go through them before you actually play with the platform. Once you play with the platform, you will see why. You don't need the success stories once you see the platform running. And if you do, I'm perfectly fine to run through them. We can send the link so you can see them at your own pace. One thing that I want you to keep from these success stories, success is not a big bang. Modernization is not a big bang. These companies have been modernizing for a long time. So depending on where you are, if you don't feel identified with these success stories, don't feel like this is not your path. Modernization happens is an iteration, is one step at a time. We start learning how each piece works, and then how do we put all of those pieces together in a way that works for our use case, for our company. So with that, I'm going to leave you with Mihai, who's going to lead the workshop. If you have questions, I'm here. Please put it down in the Q&A, in the chat, or raise your hands now before we go into the labs. I see that there is somebody with a raised hand. Is that a question or is that residual from voting before? Probably residual from voting before.
I do have a question. I've noticed that this is for doing network storage, where we've gone through different vendors and products, where some have better compression ratios, as an example. Does OpenShift, as it's going from that VM to a container, because really it ultimately ends up being your full VM in a container, rather than we have container workloads which are meant to be in the containers, as you were showing in that model. Do you see any better implementation or resource usage, or maybe resource recycling going through OpenShift as it being a container versus in a VM? And we're looking at this overall. So if I have 6 hosts and I convert them to OpenShift from VMware, am I getting a little bit better bang for my buck? Kind of like for storage, in some cases, they can do better compression than other vendors. And so then I get a little bit more out of that terabyte.
From a storage perspective, it is a complicated question because it depends a lot on your configuration and your storage and the capabilities and the IOPS that you get from your storage and how that storage is being used.
Don't limit it to storage. I'm just saying resources altogether. I'm just saying, hey, VMware, and I go, ooh, I can get one more VM on this set of physical hosts because it's better at managing the VMs as a container.
Okay. Resources is a better discussion. Like if we go vCPU or GPU, network, and memory, that's a much better discussion. In my experience, yes, you get higher density inside of OpenShift virtualization that you get out of, I don't want to say all of the others hypervisors, but the main one that you have in your mind right now. I have seen improvements in performance of particular hosts on resource utilization on CPU and memory. You can overcommit CPU. The CPU is going to throttle you the same way that it would throttle you in the normal hypervisors. Memory is a tougher business. You need to have the memory that you want to allocate, or you are going to penalize performance big time, or you are going to kill workloads. So that is a very, very good use case. How much can you improve, or how much performance can you gain? You will need to analyze your particular situation.
As well as the licensing allows you to have 128 cores, 2 sockets, and then you can hyper-thread that as well. So you can get up to 256 threads. So, I mean, you can use big boxes with one license as well.
That is one part that we didn't cover yet. That is, how is this paid? How do you pay to run OpenShift like this? OpenShift is subscribed. You buy subscriptions. You don't buy licenses from Red Hat. A subscription gives you the access to execute one node. One subscription is a one node bare metal, up to 2 socket pairs, 128 vCPUs. As Todd was saying, if you hyperthread that to 56 cores inside of the platform, that is one subscription. If you have smaller boxes, you will be paying for capacity from a subscription perspective that you're not using. Again, there is a ton of ways to optimize this and to set it up. I would recommend for you to set up an appointment and we can talk about it and talk about your particular situation, your equipment, your workloads, and then see how can we optimize it for your particular use case.
And if you want to set an appointment, any of the QR codes you see on there that are red, you can click on that, scan down on the bottom. There's a way that you can just set an appointment from that.
It is a very, very good question, though. Like we are doing this right now with a company, and we are gaining 30%. Just as an example, and I don't want, this is not a benchmark. This is not something that you should expect. But in that particular customer, we are getting 30% performance out of, again, running on bigger nodes, consolidation of infrastructure, and new CPU, new processors, and running a higher density.
Looks like Jafar has a question as well. Kaiser Passar.
I think that hand is receivable from a voting from before.
Okay. All right.
All right. So Mihai, take it off.
Mihai, I'm going to stop sharing so you can share.
Hi, my name is Mihai Kotkaru, and I will go through the workshop with you together. Todd, I have no right to share my screen. It's gray out. Maybe you can move me to...
Yeah, I'll share here. So, and then I'll keep sharing until I can get you to be able to share, or I'll keep doing it.
In any case, I just sent the address for the URL. It's in the chat. but you don't have to type it. You just can click on it. And the password is the one that you have on the screen.
All right, Mihai, try to share so that.
Oh, it's great. Only the meeting organizers and presenter can share. Can you make me a presenter, please?
All right, let me. There you go. You should be good.
Okay, excellent. Thank you very much.
Yep.
Yeah, once I log into the site, it is redirecting to the documentation page.
Okay, can you see my
Yeah.
screen?
I can
Yes.
see it.
Okay,
can see the
so clicking on that URL that Jose posted into the chat, you are coming to this page, and here is the starting point for the enter point for your our OpenShift virtualization Roadshow. Please use your registration email, and for the password, use Crossvale 0924 and access the workshop. And here is pretty much the script we are using for today's workshop. Here is the presentation already Todd and Jose gave you about OpenShift virtualization. What's more important is here at the end, each user of the lab will have three nodes, an OpenShift cluster with 3 control plane nodes and 3 worker nodes, and also a vCenter with, I think there are 3 ESXi hosts. And here are the credentials for OpenShift console and also for vCenter. Okay, in the background, I have already opened the OpenShift console. This is how OpenShift looks like for anyone who they have the chance to see OpenShift. And also here is the vSphere environment we are using right now. Going back to the script, first of all, I modify a little bit the the order we are doing the this lab. First of all, let's start with number 2, migrating existing virtual machines. And for this, we'll migrate 3 VMs from ESXi, from VMware to OpenShift. The next step will be working with virtual machines and applications. And this happens because these 2 labs are interconnected. So the lab number 6 is using the VMs on number 2. And in the second part of the lab, we are going for virtual machine management, the storage management, the network management for the virtual machine, and the backup and recovery for the virtual machine. And it's this is pretty much very good for administrators. And in the last part, we'll discuss about templates and instance type for deploying virtual machines. So let's get started. First of all, in order to migrate the virtual machines from VMware vSphere to OpenShift virtualization, in OpenShift, we need to prepare it. And for this one, we have to, okay, I'll close this one. We have to install some operators, and the operators are some application that will deploy software necessary for the functionality of the OpenShift. So here, if we change from the developer perspective to the administrator perspective and go into the operators, installed operators, here we see that we have a lot of operators installed, but pretty much the one which are very interesting for us is the OpenShift virtualization and the migration to toolkit for virtualization operator. The OpenShift virtualization operator will allow us to run virtual machines on top of OpenShift. And the migration toolkit for virtualization operator is the one that we'll use to migrate the machines from VMware to OpenShift. There are some prerequisites in order to migrate the machines. No CD-ROM to be mounted. They need to have an IP address. The operating system needs to be certified. So right now, just the 64-bit operating system are allowed to run on top of OpenShift virtualization. And the name to be only all lowercase characters to contain letters, numbers, and just the hyphens. And the name of the virtual machine to be unique. Okay. Just a question before we go far. Are you able to see this page? And do you have assigned a user and a password for the OpenShift console and for the vCenter?
Yeah, I'm able to log in.
Okay, if anyone has any issue, please post them into the Q&A section. And James from Red Hat will help you to get into the system. Okay, so let's get started. We can do it together with me, or you have some time at the end of my presentation for this virtual machine management to do it by yourself, and in case you have any issue to troubleshoot them. First of all, let's start with the vSphere environment. This is the old environment, the source environment, and here I'm not an administrator, and I'm not sure we can see. Yeah, we can see the ESX hosts. What's important here, under the vCenter, we have a Roadshow folder, and in this Roadshow folder, we have 4 virtual machines. Win, Web 1 and 2 are some Windows server running IIS, a web application. And we have also a database running on a Linux box, and an HA proxy, which is a load balancer. Going further, we'll just migrate 3 of these VMs. We'll not migrate the HA proxy because OpenShift has mechanism to do load balancer inside the cluster. Also, we have one source data store. All of 3 VMs are running on top of this one, and also we'll have a distributed port group, right, which is the networking for VMware environment. Going further, right now, we will go back to the OpenShift environment. All the migration will take place from the OpenShift side of the so on the target side. So here we have a migration, right? Menu, and this is migration menu. We define some providers, and providers are the source and the target for the virtual machines. So the VMware is the source, and these providers was defined by the system when it was deployed. We are not administrators, cluster administrators for this cluster, so the system already configured these providers for us, and the host is the existing OpenShift cluster we are talking right now. Here you can see we have the VMs. We can see VMs, we can see networks, and we can see hosts, and also the storage. Because I messed up with the order, we have to create a new project, and this project will be named VM examples-user, and the username you are using right now, right? So I'm user one, you see here in the corner. So I will create a VM examples-user one project because all my VMs will be hosted by this project. In OpenShift, the project is a space, right? And for this space, you can assign permission for the users, and that user can be administrator for this project or any other role, but can see the work for other users, pretty much. Okay, so we have this project created. Let's go back to the MTV user one project, right? And the next step would be to create a migration plan, right? In order to create a plan, we'll go to under the migration plans for virtualization and click create a plan. Here we have to select the source provider, which in our case is the VMware. And as soon as you click on the source provider, we can see all the VMs running on that one. We pretty much, and here pay attention that the name should be VM-user1 in my case. In your case, should be one of the users. So here I will choose the 3 VMs. Okay. Web 1 and okay. So I've choose the 3 VMs. You can see here. The next step will be to define a name. And in our case, as is stated into documentation, let's add move web app VMware for the name. For the source provider, okay, we selected 3 VMs. The host, the target will be the host. The target namespace is the name we created. And that one is VM examples user one in my case. In your case is VM examples user X, and X is the name of your user assigned by the system. The next section is dealing with the storage and the network mappings. So we are moving from one storage to another storage, one network segment to another segment. The source segment in the VMware, it was a segment migrating to OCP Vert, right? You can see it here. Let me make a little bit bigger. Segment migrating to OCP Vert. And we'll go to the pod network. It's fair enough for now to move it to the pod network. Pod networking, we can move it to any other segment in the OpenShift, but for now, let's keep it in the pod networking. And the next storage mapping will move from a data store, workload share 1 in my case, to a storage class. and the storage class are defined in the storage segment of the OpenShift. We'll discuss about storage classes later in this demonstration. So everything is configured right now. I will just go ahead and create the migration plan. As you see right now, the migration plan is in not ready state. It will become ready in a moment because OpenShift and MTV, which is Migration Toolkit for Virtualization. I will use these terms going further. MTV will verify if this is possible to move that VM from VMware to OpenShift. Let's give it 2 minutes here until the plan will become ready. In the meantime, I will talk to you that we are doing a cold migration right now. It is possible to do even a warm migration, but it's got some prerequisite for the source VM. Right, and is it not ready yet? Okay, let's wait a little bit. Okay, so this migration plan is ready right now, and let's start the migration, right? And we'll, if you remember, just to double check, we are moving a database and two web servers from VMware. So we are moving a database and two web servers from VMware to OpenShift. I will start the migration. And we are clicking here on the virtual machines. And let's see what happens. So pretty much, this is the database server. This is the smallest one. It's got only 4.5 gigs. The Windows servers are bigger. And we'll create the persistent volume claims. So this meaning it's allocating disks to the VM. And the persistent volume claims is equivalent of a VMDK in VMware world. Persistent volume claims are the physical disks. They are permanent. So they are keeping data forever until they will be removed. The next step would be converting the image. So the MTV is doing the conversion from the VMware format to the KubeVirt format. And this will take a while because the migration is happening over the network. As Red Hat recommends, it's good to have a large bandwidth. They recommend 10 GB for the network in order to transfer large VMs from VMware to OpenShift. Okay, so the image is converting right now. The same thing happens for all 3 VMs. So they are in the same stage. And let's monitor it a little bit. If you are doing the migration at the same time as I'm doing, might be a little bit of slowdown. We are using a shared environment, and that shared environment, it's the demo environment. So don't expect to have too much to be too powerful. right? As you see here, the one of the web servers already started this transfer V2V, and it's copying data from VMware data store to the PVC, which is persistent volume claims, PVC, into the OpenShift environment. I don't think it's too much data, but pretty much we'll have to wait a little bit. So right now, the data transfer is doing, it's happening over the network. It depends how fast your network is and how many events happening at the same time. It's better to have maybe a dedicated network to do the migration from VMware to OpenShift. And also talking to Red Hat, looking actually in as a future going further, they will do a storage offloading. So the data, instead of being copied over the network, can be done in the background by the storage. It depends what kind of storage you have right now. I'm not sure if all the providers will have this option for the storage offloading, but for now, it's just one, to be sincere. So you see, copying the data, it's pretty much fast for the WinWeb. And I think if we give 5 more minutes, all the servers will be migrated from one environment to another. As we discuss here, the mappings can be done even preventive. I mean, you can create a storage map and a network map and use this one as I mentioned before, in a GitOps process, right? You can use the GitOps tool to automate the migration of the virtual machines from VMware to OpenShift Virtualization. So it's possible. And also, they are not mentioned into the documentation, but you can also use hooks to automate some processes during the migration of the virtual machines. So 2 of the VMs are almost there. Let's wait for the WinWeb. So until we wait, I'm not sure if is there any question asked into the. There is a question that you'll have access to the environment. Yes, you'll have the access to the environment 2 more hours after this workshop will stop. Actually, for the project needs to be VM examples dot dash user, and the user number, you have it here, right? If I'm user 1, will be VM examples dash user 1. If you are user 6, your namespace will be VM examples dash user 6. And will change, right? If you are using, no, it will not change in the future. Oh, Nathan is asking about the VM. In the VMware, the database and the web VMs are already down, right? And they will be, we can see them into the VMware environment, in the OpenShift environment, excuse me. So 2 of the VMs are already migrated. As you see here, the process is already done. It took 7 minutes for the database, right? And the same, it was 9 minutes for the other, the last web server. So everything is migrated right now. We see we have the database user 1, web 1 and 2 already migrated, right? And the plan is marked as succeeded. Okay, in order to see these virtual machines, on the left, if we go to the virtualization, here is pretty much the menu taking care of the virtualization. In the OpenShift, there is another stanza here on the top, and you can click on the virtualization here under administrator, developer, and virtualization. And here are, I will just cancel this. And here you can see only the things related to the virtual machines, right? Going to the virtual machines, if you remember, here we can see the projects that have virtual machines. In my case, I have VM examples, 01s, and in case you are not able or is not working for you to finish the migration, right? You can use the this namespace with the database and web servers. Okay, so all 3 virtual machines here, I'll make this one smaller. Okay, I think it's still legible. I have the database and the Win web server 1 and 2. They keep the same name because the virtual machines are new for the OpenShift environment. As you see, they keep their name during the migration, right? And this pretty much concludes all this lab, all this section of the lab into in our presentation. Sorry, I am showing you. So we talk about the prerequisites for migration, right? When we migrate the virtual machines from VMware. And here is the process I demonstrated to you, right? When we migrate the 3 VMs. For you, this name will be different based on the username assigning you by the system. Okay, if you have any question about this part of the lab, I'll be happy to answer them.
I have one question, so let us take, we are going for the live migration production to OpenShift. So is there any continuous replications we can set it up before cutover?
Are you asking about the web migration here?
Yeah, here.
So it is possible to do web migration, right? When the VMware machine is up and running, but this will be, you need to have the CBT enabled, the block tracking to be enabled, right? And this would be a property of the source virtual machine. The machine in VMware will be up and running, And the same here, we'll create a migration plan. The migration plan is not here into the virtualization stanza of the OpenShift because it's separate from the virtualization, right? So we have to go back under the migration, transfer virtualization. The same, you create a new plan. They will see that the machine is up and running and it's got CBT, and will allow you to do the migration of that virtual machine. We'll copy all the data. So in the process of the migration here, right, we'll allocate the disk, we'll do an image conversion, we'll transfer the data and stop, right, waiting for you to shut down the machine. And this will be the manual process. When you shut down the machine and the process continues to copy the deltas for the disk, and we'll create the virtual machine in the OpenShift.
Got it.
Okay, so is there any other question here? Okay, if not, let's go further. And as I said, I'm not taking them in order. The next step will be exposing an application with a service route lab. And we're doing this one because this is related with the migration. We'll use that 3 virtual machines. We migrated from VMware to OpenShift. And if you remember here, we have an HA proxy. Just a heads up, right? The HA proxy will just transfer traffic in between the Web 1 and the Web 2 servers. And the web application is got connected to a database server into the background, right? In OpenShift, we are not using HA proxy because there are built-in mechanisms to do it's a built-in mechanism to do load balancing. So I'll show you right now how to do how this process is. We can do it together, right? If everyone has the 3 under the examples, it's got all 3 virtual machines migrated. If not, we'll take a little pause just to wait for everyone to finish the process, right? So how it works in OpenShift. In OpenShift, virtual machines are running on top of containers. So if we check here for a database, there is a pod running, and that pod is got a libvirt virtualization engine, and the virtual machine will start on top of that pod. I'll show you as soon as we start the virtual machines, right? So because the pods are ephemeral, they are changing IP addresses, right? Because this is the architecture of the Kubernetes. All the pods are not using the same static IP address. They are connected with any other pods running on top of OpenShift. So there are services, and the service identify a source and a target. And for a service, we can have a static IP address and will be an endpoint. So let's create first a service for the web servers. In order to create this one, the way services are working, because they are not monitoring IP addresses. IP addresses are ephemeral. We need to add some labels for the web servers. And in our case, for the WinWeb Server 1 and server WinWeb 02, we'll add this label. So if we are going to the WinWeb 1, will just modify the YAML, right? And pay attention that here under the templates will have a label. In my case, it's line 123. We just have to add another label, and the label will be env web app. And I will save it. This is because it's using an old one, just ignore it. It's not important. So I add it, and I will start the virtual machine. I'll do the same for the WinWeb 2. I'm going to the YAML. And on line 123, I will just add a new label. And this would be web app. You can do it the same, but just pay attention that, oops. The indentation is important for the YAML. Okay, and I'll start the virtual machine. I will start even. Okay, as I talked before, here we have a pod that is the virtual machine image is running on top of this pod. It's Kubernetes, so what can I say? So here we will discuss in the next lab about administrating the virtual machines, but pretty much we have a console for the virtual machine, and you can see how the virtual machine is starting. Would be exactly the same process for the Windows servers. Here will take a little bit of time until they'll start. Let's give them some time. In the meantime, until the virtual machine starts, let's go to the networking services. And just pay attention that services are namespaced. I mean, the virtual machine can see, or the services can see only the virtual machines running in the same namespace. First of all, let's create a service that will be will serve the two virtual machines with application web. They provided already a YAML file. I will just create the service, copying and paste the YAML file. Just pay attention that the namespace to be the one matching your user. So pretty much the name of the service will be web app, and we'll use the selector env web app, and we'll serve the port 80 under the protocol TCP. After we create the service, as you see here, we have a routing name for the service, which is just internal to the cluster. It cannot be accessed by, it can be, but right now the service can be accessed by outside of the cluster, and it's got a cluster IP, right? And all the other services trying to go to the web app will use this IP and then a web app name. And here we have the port 80 published. If we go to the ports, we'll see that the Web 1 and Web 2 are the targets for this service. So we are in a good track. In order to publish the service for the external world, we need another object in OpenShift, and this is a route. So let's create a route. In order to create the route, we can use the YAML, or we can use the form view. For this service, let's name it route web app. Okay, and we'll use the service web app. The target port will be 8080. And let's use the browser won't accept it, unencrypted traffic. So we'll use the edge and redirect. And that's pretty much everything right now. We'll create the route. And as you see here, we have a route that will be accessible from outside the cluster, right? If we click on this one, we'll get an internet server error because our application has two web servers connected to a database. We didn't create a service for the database. So right now, we have the pod of the database up and running, but we don't have a service in order for the web servers to be connected to the database server. If we are going back here, let's create a service for the database also. And as I said, there is provided a service here, YAML. We'll copy and paste the YAML. Right, the name would be database in the same namespace, and will serve port 3306 for and the selector. This is very important. This is how you actually, this is by default the label with the name of the virtual machine running. So we can use an additional label as we use for the virtual servers, for the web servers. It's web app, or you can use the name of the server itself. Let's create it. Right, so we now have database services served to the web servers. If we are going back here, we should see let's wait a little bit. So we have the web servers. Let's see if they are up and running. Oh, they are still rebooting. Oh, we have the console for the number 2. Right, so this is a core server. I think it's still rebooting. Okay, so right now, if you see here, we have the application, our application, web application up and running. It's pretty much numbering the, putting a number for the visitors and telling which server is serving the application. We can refresh it. The number was incremented from 406 to 407, but it's served by the same WinWeb server. If we keep refreshing, I think in one point in time, we'll reach the WinWeb 02 server. So these are pretty much the first part of the lab when we migrated existing virtual machines from VMware to OpenShift Virtualization. And in the second part, we demonstrated that we can use exactly the same service and configure them to serve application running on the same application running on the VMware. Okay, so we can take a break right now and wait for everyone to finish these labs. In the meantime, if you have any question about the lab, you are please ask them into the chat.
Hey, one quick question. So after the migration, should we uninstall any VMware tools or drivers, something like that, or it's part of the migration? It's taken care by the MTV itself.
Actually, this is a very good question. MTV, the newer version of the MTV, this is, as is showing here into the introduction at the end, this is using Red Hat Migration Toolkit for Virtualization, Virtual Machine 2.7.2. Right now, it's a version 2.9. So the MTV, so the Migration Toolkit for Virtual Machine right now, it's uninstalling the VMware tools and installing the QEMU drivers that come with that are required for virtual machines. And you can see this one that it's recognized the operating system running inside and everything from here. So it's yes. The question is yes, MTV right now it's capable to uninstall the VMware tools and install the QEMU drivers. Do you have any other question? So does anyone the migration was successfully for everyone, or is anyone getting any issues with the migration? Yes, please, Nathan.
Hi, yes, I had a question. It's more kind of after the fact, but once that page is up and working, like if you were to have to replace it with another server certificate from the old server, would that just be within OpenShift? You can load the server certificate that you had previously, and everyone can use that same URL to hit it?
Oh, you are talking about the certificates from the network, the service itself, right?
Yeah, like how do users, so say you move the web server from, vSphere, now it's in OpenShift, you have it working in OpenShift, and you want to turn off the vSphere one, you load the certificates into OpenShift, and then people can just hit that new URL, or would there be more work needed?
Yes, actually, it depends the method you are using, right? If the certificate will be discarded on the load balancer or on the server itself, but pretty much for the route, right? We are not talking about this one. We are into the not this one in the examples, user first, and we have a route, right? Here for the route, we can add certificates, right? And this will be the certificate for the router itself. And here, having this one, you can pretty much create a CNAME for this location and add the certificate to that CNAME, right? Or even you can add it here, right? But being, I'm not sure if you are using like wildcard certificates or not. You have to create a specific certificate for this route.
Okay, is that like a DNS entry?
This is, yes, it can be used as a DNS entry because here, if you remember, we can access the application behind it, which are going to the web servers. So in OpenShift, pretty much you can install certificates. That is possible. The router itself, if you're going back here, you see we have a route here, which is the canonical route, right? This is the default router for the whole OpenShift cluster. So all the routes will be like part of this canonical router name. So for the OpenShift cluster, if you install the certificate for your network, it will be good inside of the cluster for every route you create.
All right, thank you.
Okay, so if there are no other question, so okay, as I said, these servers have limited resources. I'll go ahead and shut them down in order to go to the next lab. So I will stop them from here. Okay, and going further, let's talk about the virtual machine management. At the end of this lab, we'll learn how to create a new virtual machine, review and modify resources for this virtual machine. We'll see the states, the power states for this virtual machine, and we'll do a live migration between hosts. I think you are already logged into the cluster. We don't need the vSphere anymore. And all the servers are stopped. Okay, so okay, in order to create a new virtual machine, let's move again to the virtualization stanza, which is pretty much usable for using managing virtual machines. Let's go to the virtual machines. Here we have the menus. And here we can see only the projects that have virtual machine containing virtual machines. And here the virtual machine, all the virtual machines. Going further, we are just using the VM examples -user namespace to create virtual machines. So first of all, let's create a new virtual machine in this VM examples project. We'll create Linux virtual machines, and the reason is because Red Hat provides some templates for virtual machines. Red Hat, Fedora, CentOS, we can use going further into this project. So in order to create a virtual machine, you see here we have a blue button, and we can create a virtual machine from an instance type or from a template. For now, let's use the template. It will be easier. And here you see we have a catalog for instances and the template catalog. The default templates are presented here into the catalog. As you see, the one with the source available are already ready to be deployed. For the Windows VM, we'll discuss how to create a template in the third part of this lab. For now, let's deploy a Fedora VM. And you see for Fedora, we have a source available. Pretty much we'll use the disk source, which will be the template default. So the disk, it's already there. We'll just change the name from this very nice name added by the system to Fedora 01. Right. And that's pretty much everything we can do. The project will use VM examples -user1 in my case. Also, we can create folders for managing the VMs. Will be easier to search them into the folders. But for now, let's just quick create a VM. As you see here, the source disk is cloned, and this is pretty much provisioning. Right, you can see here that the preparation claim it's in progress, so it's copying the disk from the source. It was already copied. And the next step will be starting the virtual machine. And it's in the running state. For the running state, running meaning the virtual machine is not yet up and running, right? Because we still have to, the machine needs to be booted, but we can follow the process here. As you see on the top, because we are deploying for a template, username and the password are pretty much assigned following the template. And this is pretty much what happens when you deploy a new virtual machine into the cloud, right? When you try to deploy a virtual machine in AWS, already give you a cloud user and a password in order for you to be connected to that virtual machine. So pretty much it took less than a minute to have a virtual machine up and running. There are some things we can discuss here under the details. We have some information we can use for the virtual machine. Here, where the machine running, this is an old version we use for the demo, but on the newer version, you even have the node on the top. The machine is running on that node. Here we have information about the snapshots, about the network, the storage, and the utilization. There are some metrics here, how much it's using. There is 16%. It's not too much, right? Because we allocated for that virtual machine a little CPU. Also, the YAML. The virtual machine is, this is the manifest for the virtual machine. You can save it and deploy many virtual machines using the same manifest. Here is the configuration. And for the configuration, every administrator needs to know how to do it, right? In order to change the memory, we are coming here under configuration details and change the vCPU and the memory, right? Save it. So now we have 2 vCPU and 4 GPU of memory. The host name, the pass-through devices, and the boot management. Under the storage, we can see the disk here, that our root disk, it's a PVC. As we discussed, it's this is the equivalent of the VMTK, and we are having a storage class. These storage class are like equivalent of the data store. As soon as you create a new virtual machine, it needs to know where to be deployed. As soon as the storage class is provided, will automatically create the disk based on the properties of this storage class. Network. Right now, we have the virtual machine in the pod network. It can access the internet for sure because it's using the OpenShift networking system and the route to go out. For the scheduling, this is how you assign a host. A host is a node pretty much for the virtual machines. And you can use node selector, tolerations, and affinity tools. And this is pretty much new, the scheduler, which is doing an equivalent of DRS, moving virtual machine in between nodes. And here it's the eviction strategy, which meaning when a node is rebooted, what that machine would do. Will move to another node or just shut down. And this is very important in case you are doing a DR, right? Which virtual machine to start and which virtual machine can wait until all the environment is up and running. For the SSH, here you can add your own SSH keys in order to connect to that virtual machine. We have a cloud init for Linux machines, and this will be at the time we'll run. We'll discuss about the cloud init further into this lab. And for the Windows machine, we have a sysprep and also the metadata with the labels and the annotations. For the events, we can see what happens if we would like to troubleshoot the virtual machines. The console, it's pretty much where you connect to the virtual machines inside the cluster. As you see, you can also use an SSH, right? Because the virtual machine will, you'd like the virtual machine to have external connectivity to the other servers into your network. The snapshots and the diagnostics. And here on the diagnostic, it's how you troubleshoot if the virtual machine has issue. So pretty much everything is about the administration of this virtual machine. For sure, as an administrator, you'll do many things, not just creating virtual machines. You have to manage the virtual machines, to add CPU memory, to add disk, to add another, to connect to another network, and so on. And you have all the tools for that virtual machine here. We didn't discuss this, but there are two abstraction for virtual machine. First, the virtual machine is got an image, and that image name is virtual machine. And we have a VMI, a virtual machine instance. And that virtual machine instance is this one, VMI, and it's running on top of a pod based on the VM image. This is how OpenShift is the architecture of the OpenShift. So we have a VM and a virtual machine instance. So keep in mind, all the changes needs to be done to the virtual machine, not the virtual machine instance. And this is why, if you remember, under the YAML file, we have a template, right? And this template is the virtual machine. So we not add the label here. We add the label under the template and restart the virtual machine in order to get all the changes applied. Okay, so to control the virtual machine state, we have here some buttons, a stop, a restart, a pause, and the start button. And also we have some actions. Right now, there are stop, restart, pause in order to control the virtual machine. If we stop the virtual machine, it's pretty much stopping the virtual machine. The pod is killed, doesn't exist anymore, and the instance will disappear. Right now, the virtual machine is stopped, right? And we can start it from the menu or from the blue triangle here. So if we start the virtual machine, a new pod is created, and we'll get an instance from the image, and we'll boot our server. So pretty much these are administrative tasks that every administrator will do to the virtual machines, configuration, and power state for the virtual machine. The next important step is to do maintenance for the infrastructure, in our case, OpenShift nodes. I am not a cluster administrator in order to show you the nodes. So for us, there are no nodes here, right? I cannot see them under administrative task. There is a compute menu that will show you how the nodes. In our case, you have to trust me. Okay. Another task for an administrator would be to migrate the virtual machines in between hosts, right? And right now, the only requirement right now is to have a storage that is read-write many in order for the virtual machine to be migrated, right? And in our case, looks like this storage that the virtual machine is on. And we can see it here on this storage class, right? Let's open it into new. So this is how the PVC looks like. And we have a 30 GB persistent volume frames with a capacity of 30 GB, and the access mode is read, write many. So the virtual machine can be migrated in between nodes. The volume mode is block, and we are using this storage class. Yeah, the storage class. And this is the definition. And if you remember the analogy for the storage class, it's a data store in VMware. Okay, going back here, I'll show you how to do a migration in between nodes. First of all, as I said, for the newer version, you'll have here the node, but right now, in order to see where that pod is running, you see it's on the node worker cluster -1. So my virtual machine is running on worker 1. To do a migration for the virtual machine under the actions, we have a migration, and we can do migration of the compute or of the storage. For the compute, we'll move the VM from one node to another. For the storage, you'll move the VM from one storage class to another. For us, we'll do a compute. If you remember, the machine was running on node number 1. It's in the migrating state. And after a little bit, the machine is migrated to a new. Let's see the new pod. So right now, the virtual machine is running on the worker 2. If you see it was a live migration, the processes are still up and running inside the virtual machine. For now, it's not possible to choose what node will be the target for the compute migration. But as you remember, there are some options under the configuration and scheduling. You can choose the node, and you can select that this virtual machine to run only in between node number 1 and number 2, or number 1 and number 3, right? And you add a selector here for the virtual machine to run. Okay, so this is pretty much how you do a migration of a virtual machine from one node to another. If you have any question about the administration and also the live migration of this of a virtual machine in OpenShift virtualization.
Yeah, is the storage migration possible, like how we do it in VMware, migrating the VMs from one data store to another? Do we have that feature here?
Yes, if you remember, I mentioned it. under migration, we have a compute migration, which is moving pretty much the memory from one node to another. But we also have a storage migration. And this storage migration is moving the VM from one storage class to another, which I mentioned before would be the equivalent of a data store. So if you do a storage migration, you can do the entire virtual machine or selected volumes, right? And they're asking you, where would you like to move? I can move it here, right? And this is moving between data stores, pretty much equivalent of storage migration in VMware.
Okay, so let's say the OpenShift cluster is connected to two different storage arrays with like two different storage class. So it's possible to migrate between the arrays.
Yes, for sure. It is as soon as the node has access to that storage, you can move it from because the storage classes are pretty much abstraction of the storage array behind. You just define the storage classes, and as soon as they are read-write many, you can do a storage migration from one storage class to another storage class.
Okay, fine.
It is possible to, there are some questions here. Mahesh asked, it is possible to migrate templates from VMware to OpenShift. You convert them to a VM and migrate it to OpenShift and convert it back to a template. We'll discuss a template in the third part of this lab. And also, if you would like to create new templates, we'll discuss the process of creating templates into the last lab. Okay. Yeah, James already answered some questions here. Thank you, James. Okay, let's go to the next part of the lab, and let's discuss about storage management in OpenShift. Okay, so as we discussed, the equivalent of a VMDK is a PVC. And in order to assign a PVC to a new virtual machine, there are no restrictions on storage protocol used. Can be used NFS, iSCSI, Fiber Channel, and so on. The only request is to have read-write many access mode in order to migrate virtual machines from one cluster from one node to another, or from one storage class to another storage class. So pretty much having defined a storage class, which is an abstraction of the storage array behind. So you can have whatever storage array you want. As soon as you can, it's using a CSI driver can create a storage class, and that storage class can provide PVCs for the virtual machine. Right? And going back here for our VM, we already, under the storage, we already check the persistent volume claims for the virtual machine. As you remember, we ask for a 30 GB disk for this virtual machine, and it's on top of a storage class. And this was provided automatically by the storage. The volume mode is block for the virtual machines. Access mode, read-write many. and it's got a capacity of 30 GB. It is the same as in VMware. We can have a thin provision or assign all the disk at once at the time you create this PVC. Another important part of administration is to create snapshots. And this pretty much relies on CSI storage provider snapshot capability. So it depends if you have an array that provides the CSI provides storage snapshot capability or not, right? So in our case, we have an ODF, OpenShift Data Foundation, that will provide snapshots in order to take a snapshot of a virtual machine. It's a very easy process. As you see right now, we don't have any snapshot, right? So going here on the top of the snapshots, we just take a snapshot, we give it a name, and save it. And in much of a second, the operation is complete. We already have a snapshot taken of that virtual machine. Just keep in mind that these snapshots are not, they don't provide backup or disaster recovery capabilities. They are just point in times, right? So if something happened with the PVC, you cannot restore it. So the snapshot will be gone also. So if we create this snapshot, let's demonstrate it, that this point in time, we can restore it, the virtual machine, from this snapshot, right? Right now, I cannot restore it, right? Because the machine is up and running. So we need to have the virtual machine powered off, stopped, in order to restore this snapshot. Let's do something nasty to the virtual machine. Let's log in using the Fedora name. The credentials are here on the top. We just copy it and we can pass the content. Okay, and right now we see we are on the top on the console of the virtual machine. What they said here, let's run, let's remove the group. Sudo rm-rf boot grep2, and let's execute shutdown. Okay, R now. So we just removed the group. This virtual machine won't be able to restart the operating system. As you see here, we are into the group and waiting for the operating system to start. Okay, let's restore the snapshot. Let's first stop the virtual machine. It's not stopping because it's not into a good state. We have here under action the option to force stop. So the virtual machine is now stopped, right? Going back to the snapshots, let's restore the virtual machine from the red snapshot. As you have only one snapshot, it was presented to us. Let's restore it. And it looks like the operation took less than 5 seconds. Okay, let's see what we did. Let's start the virtual machine. Okay, and let's see if it starts. We can go here under console, and boom, our virtual machine is starting. So this demonstrates that the snapshot just restored the machine to a point in time where the virtual machine was able to boot. The next operation I would like to demonstrate to you is how you can clone a virtual machine. And this process, it's a very easy process. Here under actions, so we have Fedora 01. Let's clone it to another machine. The option we have under action, we can find the clone option. And let's name the second VM Fedora 02. Let's not start it for now, because the clone of this virtual machine, if even the name, we name it Fedora 02, being an exact copy of Fedora 01 inside the operating system, the name will be the same Fedora 1, right? And we'll keep everything from its source clone. Okay, let's start the cloning process, and this will be very fast, right? We have a new virtual machine here, and it stopped. Okay. In order to customize it and make it Fedora 02, we have to go under YAML and modify some values here. And what I said is the label on 01, let's name it 02. And also we have the word.io domain. And let's change it to 2 and save it. So we have the name, we didn't change that one. We have on line 132, the app was changed to Fedora 02, and the label was changed to Fedora 02, and this was saved. Let's start the virtual machine. Okay, let's give it a little bit of time for it to start. Okay, so as you see, we have a new virtual machine up and running with another identity, and the name is Fedora 02, right? The other was Fedora 01, and we have different credentials. So for now, we can conclude this storage management. If you have any question about the storage for OpenShift and virtual machines running on top of the OpenShift virtualization, so please ask. I'm okay. So if you don't have any question, let's go further and talk about the networking. Okay, so for the networking, if you remember, there is a software-defined network inside the OpenShift, and we already discussed about the service and the route objects in OpenShift that will provide connectivity in between virtual machines and other virtual machines, and also from a virtual machine to external world. The way network is managed inside an OpenShift, and I will demonstrate it you here. So let's go first to the administration stanza and to the networking. Right. First of all, we can see the node network state. We have the network state. And here, as I mentioned, we have the control plane, 3 control plane and 3 worker nodes. They have Ethernet, and these are pretty much the standard created by installation of the OpenShift. But for the worker nodes, we have 3 Ethernet cards, right? And the Genesis one, which is something else. And you see, this one is got an IP address. Also, for the worker nodes, each worker node, actually, they have a Linux bridge. And this Linux bridge is BR flat, and it's kind of a VS switch in VMware. It's exactly the same. It creates an overlay, it creates a network in between the nodes, and all the virtual machines can get a port and can connect through the node NIC to the external world. Right, so we have a Linux bridge here. How that Linux bridge was created, as I mentioned, I'm not a cluster administrator, but in order to create bridges, Linux bridges for nodes, we are using node network configuration policy, and pretty much this is a policy. And I can show here the YAML file. The YAML file is pretty much this part, right? When it's using a port name, and on top of that port name, it's creating a Linux bridge. What's important here is that this name on line 50, the name of the bridge. We have a selector, right? And here the selector, it says just install this one only for the worker nodes. Going back here, we have enactment states, right? And it says this configuration policy is only available for the worker nodes. You see the control plane nodes are not here. And all of them show that's available. So the bridge is available on all 3 worker nodes. Okay, and this is pretty much done by an operator that it's installed on, let me see, I'm not sure if I can see it here. As I said, I can't see all the, we have an NM state operator, and that NM state operator will allow us to see, to create the network policies and create network attachment definitions. Okay, if you remember, Jose mentioned that OpenShift is pretty much on the concept of a cloud. And for the cloud, we have the opportunity to create, for example, in AWS, it's a elastic network interface. When you create an interface and assign that interface, a network interface to an instance. It's exactly the same here in OpenShift when you create a network attachment definition. And this network attachment definition is a NIC, or a definition of a NIC, right? Because you can create one with a static IP address and assign it to a specific virtual machine. When you create, or you can create a generic one and assign to more than one virtual machine, and that virtual machines will get an IP address from a DHCP network the ACP server running in the network. Okay, so let's create a network attachment definition that is pretty much need that be assigned to our virtual machines. So keep in mind the network attachment definitions are namespace. So in order to create NAT seen by the virtual machine, we have to create it in our namespace VM examples-user1. So let's create it one here. Let's name it flat network as mentioned here. And the network type would be a Linux bridge. The name is BR flat. This is, if I spell it correctly. And also we have the opportunity to assign VLAN tags here, right? But pretty much it's like everything we can add here. We can also add a description, CNV. Okay, and we'll create it. Nothing else here. Okay, after we create this network attachment definition, let's assign it to a virtual machine. So if you go back to the virtualization, let's assign it to Fedora 1, right? In order to assign it, we go to the configuration menu under network, and we add a new network interface. Let's name it NIC flat. Will be Vert.io, and we'll select the network attachment definition, flat network we just defined, and save it. This is pending a restart because if you remember, we have a VM and a VM instance. So let's restart the virtual machine. And in the meantime, let's do the same thing for the Fedora 2. So under configuration, we go to network. We add the network interface, and let's name it the same, flat, and attach it to here, and save it. Again, it's pending changes because it needs to be applied to the virtual machine, not to a virtual machine instance. So we just restart the virtual machine. Okay, and if you check here under the network, let me make it bigger. You see right now we have two networks attached to this virtual machine. The default one, which is a masquerade, and the NIC flat, which is connected to the external world, right? As mentioned into the documentation, there is a DHCP server running into the network, providing IPs in 192.168.67, no, 64.0/18. So we have a NIC in that network for the Fedora 1, and also it looks like this guy didn't get an IP address yet. Yeah, might be an issue here with the volume. Okay, let's restart it. Yeah, might be an issue with this virtual machine. Okay, I'm like, what happened here and why is not rebooting? Stop. And start. Okay, and until this one restarts, the last topic is about user-defined networks. And these user-defined networks are a replacement of the masquerade network using the virtual machine. So if you remember for Fedora 01, we have a NIC as configured the pod in the pod networking and masquerade. And for the Kubernetes and the OpenShift also, this pod networking, all the virtual machines and pods can talk to each other over the pod networking, right? And to restrict the traffic, you need to create networking policies. Another option would be to create user-defined networks when you create a project or a namespace. And in that project, to instead of having the pod networking, to assign a range of IP addresses that to be assigned to the virtual machines. What user-defined networks provide? It's enhanced network isolation for security, network flexibility, simplified network management, and other advanced capabilities. Just keep in mind that for the OpenShift, it's just the layer 2 topology for user-defined networks. So how we work with the user-defined networks? Let's go to the user-defined networks, and you see we have here this option. Let's change the project to the user one, UDN, right? And here, let's create a user-defined network with a subnet defined. So the user-defined network can be a cluster user-defined network that many projects can talk to each other, or just be a user-defined network. Only the virtual machines inside that project can talk to each other, but cannot talk. Any other machines cannot talk to that virtual machine in this project. For us, let's create a user-defined network here, and we'll just assign a subnet, and I'll copy and paste from here. It would be faster, and create it. As you see here, we have only the primary. The secondary UDN is not yet supported for OpenShift. The network was created, and also a network attachment definition has been created. And we are using the subnet defined 192.168.254.0, and the role is primary, and the topology is only layer 2. Okay, and going here to network attachment definition, looks like the primary UDN network attachment definition was already created, and it's a user-defined network. Okay, in order to demonstrate this, let's create a virtual machine. A virtual machine to use UDN, user-defined network. It needs a little bit of adjustment for the YAML. So the easiest way to deploy a virtual machine is using a manifest. To deploy a virtual machine using a manifest, you just go here into the plus and import from YAML. I will copy and paste the definition you have into the script for this lab, and I will create it, the virtual machine. If you see here under projects, under virtualization projects, I have under user UDN, I have a Fedora UDN virtual machine, which is provisioning right now. And as soon as it's provisioned, what we are interested in is what IP address it's got, right? So let's wait a little bit for the machine to be provisioning. It's starting right now. And in a few moments, we will be able to connect to its console. But in the meantime, just check here under the network. We have the primary UDN, and we have an IP address inside our user-defined network. So if we do a comparison between Fedora 01, right, which it's got the default network in the pods network, which is the default network for containers and virtual machines. Our new virtual machine deployed in this in the UDN, it's got a IP address from the range we define for the project. Just keep in mind, it's you need to define the project first and annotate it for UDN. You cannot do it after the project is created. So then the moment you deploy the project, you have to annotate it to support UDN. Okay, so here it's finishing the presentation for the networking. If you have any question, please ask them now. Okay, so if not, what we can do is go to the last part of second lab and do a backup and restore of the virtual machines. Okay, I will shut down this one just to conserve the resources. Oh, I think. Okay, so we discussed about networking. I will ask again, maybe someone thinking of a question about networking. If there are no questions, let's go further to the next section of the lab and discuss about backup and recovery of the virtual machines. Keep in mind that there are many solutions for the backup. Fortunately, OpenShift comes with its own solution. The name is OADP, and this is installing an operator. And based on that operator, we can perform backup and restores of virtual machines or an entire project and so on, right? I'll go back here, and I think we have an operator named OADP. Just keep in mind, this operator requires an object storage, like an S3 bucket, in order to do the backup. So for the OADP operator, which is based on Valero, right? What is defined? It's a data protection application and a backup storage location. As I mentioned, not being a cluster administrator, the system already provided, installed this installed operator and also configure it with a data protection application and the backup storage location. Next step for us is to do a backup and restore. What is important here in OADP, if we check the resources, it looks like under configuration that the Valero can do the OpenShift and also the KubeVirt, right? So it can backup containers and also the virtual machines. So let's demonstrate how we can do a backup of a virtual machine. And in our case, we'll do a backup of Fedora 02. Okay, so going back to the operators, right? Going to the backup, we can create a backup, and I'll just copy and paste the definition they provided into the script. Okay, what's important here? We give it a name, and in what namespace? What virtual machine to backup? In our case, the one that match the labels, app, Fedora, or the name of the virtual machines, because line 15, it's pretty much the name of the virtual machine. We are using it, and the virtual machine has a label with this one, can be provided in services and even here into the backup, and also where to do the backup. We just go ahead and create it. And as you see, the backup started right away. It's in progress. It's creating a backup on the S3. I have no access to that S3 to show you where it is and how what object created there, but trust me, it's doing a good job. So after a few seconds, you see the phase, it's already created, and we have a backup of the Fedora 02. Let's see if we can restore it. So let's go to the virtualization and remove it. If you go to the action, we have the option to delete the virtual machine and also delete the disk. So as you can see, we have no Fedora 02 now. If you go back to the operators on the OpenShift operator, we have the option to restore it. And the same will create a restore. The script provides a YAML for the restore. And it's using backup name, backup Fedora 02, and will restore the PVs also. So as soon as we click the create, the process starts, and looks like it's already completed. So let's verify. If you go back to the virtual machines under user 1, looks like we have a Fedora 02 machine that can be started. And it's up and running. Just keep in mind that going back here, so the machine is running, and it's got all the data to be booted. Just keep in mind that here under OADP, this backup and restore processes can be scheduled with a cron job and run it. Maybe it depends on your company policy. Can be run every day or maybe every half an hour and so on. And you'll have a copy for that virtual machine. The restore can be done in the same namespace or in another namespace, right? Because if you just need some information from that backup, not need to restore the whole virtual machine, you can restore it in another namespace, extract the information from there, and remove the restoration. Okay, so this pretty much concludes the second lab we are doing here. If you have any question about the virtual machine management, storage, network, backup and recovery, um, please ask them right away. So right now, you having the script here, you have we still have 1 hour and 12 minutes for the third part of the lab. So if you'd like to get some experience with OpenShift virtualization, please go ahead and deploy virtual machines, modify the network, do some stuff. Just keep in mind you are kind of limited on kind of the action you can do. But in that enterprise, keep in mind that each admin has access to only part of the, it depends the size of the organization for sure, but pretty much you have an admin for a group of servers, right? And you create a namespace, assign that user admin for the namespace, move the VMs to that namespace, and the admin can do whatever is required to manage the environment. Create virtual machines, remove virtual machines do a backup, restore a backup, create snapshots, and so on. Assign networks, connect to other computers. We didn't discuss about the network policies, but they are not part of this lab. So I will let you play with this script, and I will monitor the chat for your questions. And in 10 minutes, we will be back and start working with templates. If everyone agrees. Okay, welcome back. Let's start the last part of our lab here. And in this part, we will discuss about template and instance type management. They advise us to shut down all the virtual machine as the resources are limited. Let's start with the Windows VM template because this would be time consuming. It's will take a longer time than a Linux VM to be deployed. So in order to create a Windows template, we'll install a Microsoft Windows 2019 using an ISO that is hosted on a web server. So let's get back to our environment. And here, if you go to under the virtualization to the catalog, we have a template catalog here. And you see here, we have tiles for many operating systems. Some of them, they have a source available, meaning the operating system is already installed and will be very easy to deploy a virtual machine. But other than, and we'll deploy in the second part of this lab, Linux VM. But right now, let's focus on a Windows VM. So in order to install a Microsoft Windows Server 2019 VM, we don't have a boot image, but we can create one, and we can boot from a CD. For the CD, we use the URL. And as you see, the URL is provided here into the script. 1 second. Okay, and let's make it 5 GB. It's not bigger than that. We'll leave this source as blank, and we need to mount the Windows driver in order for the operating system to find the the drivers and install it. Let's leave it 1 CPU and 1 gig of memory. And let's name the machine, as I said here, WinSysPrep. And we'll start the virtual machine after creation. But first, let's customize the virtual machine. And I said to change the UEFI to a BIOS and save it. Also, we have the option to configure the virtual machine using unattended scripts. So for the customized virtual machine, we go on the scripts menu. And here on the bottom, we have the sysprep for Windows. We'll go to edit, and in the same lab instruction, we have an auto-attended XML file. We'll copy it and paste it here and save it. So it creates a config map that will be attached in the moment the machine will be deployed. Okay, and that's pretty much everything. Let's create the virtual machine. The virtual machine gets created. It's taking a little bit of time in order to create actually to copy the ISO files from the web server to here. I think we have the option to see how the status is for pending, for creating it, importing in progress. You can see so the CD-ROM, the ISO, it's copied over the network to PVC here in the OpenShift, and that PVC will be mounted to our server and will boot from that CD. So it's 8% will be ready in, let's give it 2 more minutes in order to to finish the import and start the server. As soon as this will be ready, we'll see that the status from the virtual machine will be changed from provisioning to starting. Again, under diagnostic, we can see what's the progress for the ISO files to be copied. If you remember, the ISO, it's 5 GB. It will take a little bit of time to be copied over. Yes, 1 second. So Mahesh, you have the link for the lab, right? And you log in with your email address and the password. Password is okay. Sorry, going back. It's the import process. It's 70% now. So it depends how many users would be, because the lab can be available for another 2 hours. And if you don't have time today and you'd like to connect to this lab tomorrow, you have to send me an email and let me know exactly what time, and I can start the instances, and you can log in and perform the lab. Srini, is this okay for you? Would you like to do it today or maybe tomorrow? Would be the lab will be tomorrow. Yeah, just send me an email with the exact time. Would you like to connect? Will take you 2 or 3 hours, maybe 4 hours. It depends on your time, and it will be available for you to log in. Okay. Okay, so going back here, the CD-ROM, it's almost provisioned. It's 100%. Our VM, it's in the starting. And you see here, we have the installation CD-ROM, and also the drivers and the root disks are all connected to our VM. Okay, it's running right now. If we go to the console, you see the standard process for installing Windows 2019, sorry. It's nothing special here. And because we have unattended XML file downloaded here, the process continues without asking us any question. And in maybe 10 minutes, we'll have a brand new Windows 2029 VM up and running. Until we wait for this process to finish, let's go back to, so we are here when we start installing the virtual machine, right? We uploaded the XML, and right now is installing, right? So we are at the 17th step here, but it doesn't make sense to wait for it. Let's see how we clone and customize a template, right? And for this, we'll do it for Linux VM, which is way faster than Linux than a Windows VM. So if we go back to the catalog, we'll see under catalog we'll have a lot of VMs. Right, based on the operating system. But under templates, because we'd like to create a template. So right now, here we are in the VM examples user one project. But if we move to the OpenShift projects, we'll see we have a lot of templates that Red Hat provides for us. And some of them, they have a source available. And source available meaning the operating system is already installed on that PVC, right? So we'll deploy a CentOS. So if we are looking here for a CentOS small server, this one, it looks like the templates provided by Red Hat are not editable. We'd like to have our CentOS stream server with custom settings. So we'll just let's go here and create a new custom template. Okay, let's name it as into the project. The template name will be CentOS Stream 9 Server DB small. So we have a DB small here, and we'll add it in our OpenShift examples users. The template display name will be CentOS Stream 9 VM and will be database template small. And we can put a provider and workshop. And let's clone it. Okay, right now we have the opportunity to customize our new template. And what we do here is let's change the CPU and memory from 1 CPU to 2 CPUs, and memory from 2 CPUs to 4 CPUs, and save it. It's right away moved. And also, we'd like to make it a database server. In order to make it a database server for Linux virtual machines, we can use Cloud Init. And here we have a Cloud Init examples. I'll just copy and paste. So we'll just go to Cloud Init, edit. We'll go to the script. We'll remove the existing data and add our data. What it's pretty much doing is creating a user with the name CentOS, and we'll create a password that will not expire. We'll also install some packages, a MariaDB server, and we'll run the command. We'll enable the service MariaDB, and we'll start it. So at the end, if we deploy a virtual machine from this template, we expect to have MariaDB up and running on that virtual machine. So let's save it and apply the configuration. Okay, so that's pretty much everything. Disk network. We can also modify the disk, the network interfaces, add more disk, and so on, and add other parameters here. Okay, so we have a new template right now. If we go back to the catalog, let's deploy a virtual machine from the catalog. As you see, it doesn't show up here because it's a user template. It's a template we created. And if you remember the name, it was CentOS Stream 9 VM and the database template small. Let's deploy it from here. We'll keep everything as it is. We'll just create a virtual machine. And it's supposed to change the name, but this is the maroon hamster. 53, it's a nice name, so let's keep it. It's provisioning, meaning it's cloning the PVC of the CentOS 9 virtual machine. And this will take a little bit of time. In the meantime, if we go back to our virtual machine, Windows virtual machine, it's still configuring, but as you see, the process is going, it's getting ready, the virtual machine. Let's go back to the CentOS, will be faster. It's starting right now. It's even running. So the already configured operating system is there. And at the end, after the virtual machine is up and running, we'll start installing MariaDB. Let's wait a little bit from.
Hey, Mihai, while we're waiting on the virtual machine to come up, can I share my screen and just show some people a couple resources and things that they have available to them?
Yes, for sure.
Yeah, let me
All
just,
yours.
yep, while we're waiting for the virtual machines to come up, I just wanted to make sure, hopefully you guys came into this event and learned a lot about OpenShift virtualization. Maybe also learned a lot about Crossvale, kind of what we do, what we're here for. Learned a lot about Red Hat. Hopefully this has been a great event for you to understand, what you can do with OpenShift virtualization and help you make some decisions on your next steps. So I just wanted to give you a couple things here that you might want to take a screenshot of this. Obviously, we'll send out some stuff to you guys afterwards as follow-up, but couple next steps that you may have is to take the container confidence quiz. So that QR code, that link will get you to a quiz where you can put in some information about your environment and we can get you back customized results back that will provide you with some insight on what you can do to help you move to that next step to be container confident. And then also we have for those of you that showed up to the workshop and was able to work through this, we actually have a special offer for you as well. You can schedule a consultation to qualify for a free OpenShift virtualization assessment. Normally one of these assessments takes about 2 weeks of work where we come in and we work with your team to be able to help you understand how to architect the solution that you would need, as well as how to take a look at your workloads and build out what your migration strategy should be on that. It's a very high value thing that you can get for understanding how virtualization can work for you. But fill out, come to this QR code. You can fill out the contact form about and specify that you are interested in the free OpenShift virtualization assessment. And then we can set up a meeting with you to walk through some of the details on how that works. So that being said, I'm going to hand it back over to Mihai. And please, if you have any questions, feel free to reach out to either myself, Todd Millard, I'm CEO, or Mike Cohurst, Director of Sales. Troy Love is also on here that covers the West and Central. So thank you guys for showing up, and I will hand it back over to Mihai. Thank you, Mihai. This has been super awesome so far.
Okay, thank you, Todd. I will share my screen again. Okay, can you see my screen?
Yes.
Okay, so the CentOS new virtual machine is deployed. Let's log in. The username is here on top, guest login credentials. Let's use CentOS as the user, and we'll copy and paste. Okay, so we are at the console. Sorry. Here, and let's see if the MariaDB exists. In order to do this, let's do a sudo MySQL -u root. As you see here, we have an instance of MariaDB installed on this server, and we deploy the CentOS from vanilla image template inside the cluster. Okay, so let's finish with this one. And that's pretty much everything with the how to deploy from an existing template inside the OpenShift. Let's go back to, actually, let me shut down this CentOS and go back to our sysprep Windows 2019 server, which is up and running. Okay, as you see here, it is up and running. So the next step will be to customize this image. Okay, so we have a running 2019 server. And let's shut it down here. Right, and let's stop it, the virtual machine. And let's create a clone of the persistent volume claims, and we'll use that clone to deploy another virtual machine. Actually, we'll use that clone as a template in order to deploy another virtual machine. The easiest way I found to find the disk is just go to the storage. And as you see here, we have the sysprep PVC here, right? And the next step is to clone the PVC. And we'll just create a PVC that is named as in the documentation. I'll copy and paste just to be sure everything is okay. And we'll have shared access, read, write many. And let's put it in the storage class that is immediate. And let's clone it. So we already have a new PVC that is already bounded. It's on storage class Ceph RBD immediate. It's block, read, write many, and it's 60 GB capacity. Okay, we'll use this one in order to deploy many VMs into the future. So let's see how can we deploy using already sysprepped machine. If we go to the catalog, on the template catalog, we'll just choose the same Windows Server 2019. And as the disk, we use a PVC clone PVC. We are using here in the project VM examples, user one, and we have Windows sysprep template, which is the one we created. We just have to do only one change and change from the UEFI to BIOS and save it. Okay, let's create a new virtual machine. And this is our new virtual machine from a cloned. Right now, the PVC is cloned for having the source, the PVC we created before. And in a few moments, we'll have a functional Windows 2019 server up and running. Let's wait a little bit for the process to start. And here we go. So as you see here, we were able to deploy a new server from a template, and it took us less than 5 minutes, maybe less than that one. So here are the two methods to create your own template, and for the Windows to deploy a new virtual machine from a cloned PVC. So we have a new virtual machine up and running. And the last step here is to talk about the instance type. As you remember, Jose told you about that OpenShift is the cloud infrastructure. So if you'd like to deploy a virtual machine in any cloud, they will ask you about an instance type, right? The same happens here. We have instance type defined by OpenShift cluster. So if you go to the catalog into the let's change it to is not important. It's in examples. Okay, and let's use the Red 9 virtual machine. And here we have instance type. There are Red Hat provided, and you can create your own, right? But let's choose one. And these are, as it says here, the U series is quite neutral and provides resources for general purpose application. Use that abbreviation for universal, hitting that at the universal towards workloads. VMs of instance type will share physical CPU cores on a time slice basis with other VMs. But we have other types like the N series, which is designed for network intensive workloads. So O series, which are memory overcommitted pre-configured, the CX series, which are additional dedicated CPUs, and M series, which are for memory intensive workloads. So here we can even choose the number of CPUs and memory. Let's leave it 1 CPU and 4 GB of memory. We can change the name if you'd like, and just create a virtual machine. And this will deploy a new virtual machine, right? So as you can see here, we have an instance type and a preference. So instance type, it was U1, the dot medium, and the preference was rel 9. The instance is provisioning right now because rel 9 already have a boot disk. And in the minutes, we'll have a new rel 9 server up and running. Okay, as you see here, the rel 9 operating system is booting, and what is important is the preference and the instance type we are using. Okay, so the server is up and running, waiting for the username and the password. Okay, and this pretty much concludes our lab for today. You still have half an hour to play and do a hands-on training with these clusters. You can create new templates, create new VMs, configure the network, configure the storage, and so on. And I will monitor the chat for your questions. Also into the chat, I put my email address. And if you'd like to, or you didn't have time today to do the hands-on and to execute, to go through all the steps into the script for the, experience OpenShift virtualization, just send me an email and I will spin up the demo instances Just let me know the time. I cannot leave them running for a long period of time. So please let me know for how long you need it, and I'll spin them. I'll let you know. And at the end, please let me know to shut them down.
And thank you, everybody, for coming out. Hopefully this was a great experience for you. We love any feedback. We'll send out some follow-up emails if there's anything that you feel like would be good feedback to let us know on things that we did well, things that we could improve upon. We'd love to hear from you. Additionally, we would love to help you guys with any work you need on assessing moving forward with the OpenShift virtualization. Before we go, any final questions? All right. Thank you, everybody.
So the lab will be available